Archival footage of the B-36 Peacemaker, the first intercontinental nuclear bomber, massive, intimidating, and weird. The conveyor, B-36 Peacemaker, had 6 giant propellers, but they faced backwards. Cut to XB-35, Rutan Voyager, Wright Flyer clips, and it wasn't alone. The XB-35 flying wing, the Rutan Voyager, which flew around the world without refueling, even the Wright Flyer, the very first airplane, used rear-facing propellers. So, what happened? Why did we go from pushing planes through the air to pulling them? The answer isn't just about looks, it's about noise, efficiency, safeties, and even a lost nuclear bomb. But let's dig in. In aviation lingo, there are 2 main types of propeller configurations. Tractor propeller in the front, it pulls the aircraft. Pusher propeller in the back, it pushes the aircraft. At first glance, pushing sounds simpler. After all, we push shopping carts, not pull them. But in aviation, the rules are different. The Wright brothers put their props in the back. Why? Well, 2 reasons. 1, clear view for reconnaissance, nothing blocking the front. 2, aerodynamic theory. They believed undisturbed airflow over the wings was crucial. And they weren't wrong. Wind tunnel tests show smoother airflow without a front propeller disturbing things. Less drag, better efficiency. But that's where the good news ends. Here's the thing, by the time air gets to the rear propeller, it's already turbulent. This creates problems. The propeller blades experience constantly changing pressure. This causes vibrations, which leads to noise and mechanical stress. The noise can spike at specific speeds or angles due to resonance. Even the number of blades matters. Odd numbers can reduce vibration build-up, but it's still a band-aid. Bottom line, rear props equal sign messy airflow equal sign noisy flight. Visual bullet casing hitting rear prop, emergency parachute tangled. Pushers introduce dangerous situations. Ejected debris, or even a pilot bailing out, could collide with the spinning blades. Emergency parachutes, harder to deploy without hitting the prop. On the ground, foreign object debris, FOD, kicked up by the nose wheel can be sucked into rear props. And there's more. Pusher props are also vulnerable to prop strikes during rotation on takeoff. Use a smaller prop to avoid that, you lose power. It's a tricky trade-off. Engines in pusher setups are harder to cool. Why? Because there's no direct airflow hitting them when the plane's stationary or taxiing. Take the B-36 Peacemaker. It had massive R4360 engines designed for tractor setups. But when they flipped the design, the carburetor came first in the airflow. Cold air caused carburetor icing, which led to engine fires, one of which contributed to the first ever loss of a US nuclear bomb in 1950. Yep, a backwards engine cost the Air Force a nuke. So why did WWI fighters like the DH? 2 stick with rear props, because they wanted to shoot forward without shredding their own propellers. Until 1915, when a Dutch engineer, Anthony Fokker, developed a synchronizer gear that let bullets fire through a spinning prop. That innovation changed the game. Soon engineers realized the tractor configuration just made more sense. Easier engine cooling, cleaner maintenance, fewer vibration issues, and more dynamic stability. When a propeller is in front, it blasts air over the wings and tail surfaces. Even when the plane is nearly stalled, that helps pilots regain control faster. Plus, the weight of the engine in front makes planes nose heavy, like a dart, naturally more stable in flight. Even though most propeller aircraft today are pullers, the pusher principle didn't die, it evolved. Jet engines are technically pushers, and they dominate aviation now. You'll also see pusher props on some UAVs, experimental planes, and amphibians where it makes sense. Oh, and for the curious, why do ships still use rear propellers? Simple. Because there's no lift in water like in air. Drag rules the game, and placing the prop in the back keeps it safe from debris and damage. Narrator, on camera or voiceover. So, why did airplane propellers move from the back to the front? Because aerodynamics, noise, cooling, safety, and stability all said it's better to pull than to push. But as with most things in aviation, what looks like a simple design choice is actually the result of decades of trial, error, and evolution. Because in the end, to move aviation forward, we had to start pulling it. Outro music plus CTA text on screen. Like, share, and subscribe for more deep dives into aviation and tech history. Drop a comment. Would you ride a plane with a rear propeller?